In this work, we show that a challenging bolt tightening task using a ratchet can be learned from a small set of demonstrations by modeling spatial relations between visual features and robot end effectors. The difficulty lies in the uncertainty of the ratchet pose after grasping and the high precision required for mating the socket to the bolt. The task may fail when the socket is not aligned with the bolt. There are two main contributions in this work. The first is that we propose to classify action demonstrations into three different types based on the interaction between visual features and robot end effectors. In our second contribution, we introduce an approach that distills multiple demonstrations of the same action to produce more precise movements by identifying consistent spatial relations. We show that a small set of demonstrations can significantly decrease action error. In this work, aspects are composed from multiple sensory resources. Our models use features from convolutional neural networks, force torque sensors, and proprioceptive information. Aspects observed during demonstration are connected to controllers to form aspect transition graphs. 5 aspect transition graphs are generated to model the ratchet task. With this approach, we show that Robonaut 2 is capable of grasping the ratchet, tightening a bolt, and putting the ratchet back onto a tool holder. The video is sped up by 16x while the robot is idle, waiting for point clouds and computing visual features. The wait time is abnormally long due to limited bandwidth.